Gerrit code review on multi-site on Kubernetes. I know it's the second talk today about Kubernetes Gerrit, but that's only because it's a cool topic. And we're going to be tackling it from a slightly different angle. I'm glad Matthias did all the nitty-gritty dive deep into Kubernetes itself. We're going to talk a bit more about the multi-site aspect of it. I've actually realized it's the first summit since I've been around that there's not 15 talks about multi-site. This is actually the only one. But there might be some more tomorrow, who knows. I'm Danny, for those of you that don't know me. I'm an engineering manager at GerritForge, community manager, bit of a contributor as well, but nothing too major. All right, so agenda. What is currently Kubernetes Gerrit that Matthias did a great job talking about, multi-site design and implementation, and then a quick demo. Kubernetes Gerrit. So the few differences from what Matthias showed this morning, so I'll go over that again in a bit. But essentially what we've got here is a multi-primary Gerrit setup based on 3 pods. And I think it's always important to have at least 3 pods, because if you want to do some rolling upgrades, at least you've always got 2 pods up and running at the same time. You could have more. This is just a basic setup to begin with. We'll see how we make it. We'll make it feel like one instance, is how I like to say it, using Istio, which is a really powerful open source service mesh that you can use natively in Kubernetes, and uses Envoy as a side container to enable us to do some really cool stuff with routing and all of that. It's a bit equivalent to HA proxy and allows you to handle incoming calls, and it can be routed in different ways and to different services. One really cool thing that you can do, it also allows you to replay traffic that you've had through those instances. So if then you want to use that for your Gatling test later on, or just testing things in staging, you can do that as well. There's also traffic management with custom rules. It can help with rolling upgrades and a bunch of more things. Also stickiness and sharding. So it handles that for you as well. So Kubernetes Gerrit uses Istio out of the box, but you can change it. It doesn't need to be that. And you can integrate it with other systems if you want. Now, the important things here is there's no shared file system. So we've seen a few times today how NFS can be a bit of a limiting factor and cause a few problems. However, in multi-site, that's the main differentiation between HA and multi-site. We don't have a shared file system. Each pod, as we'll see in a second, has its own site and config and all, caches and everything, but I'll talk about that in a second. Crucially here, what we're using Apache Kafka and Zookeeper for syncing between the various nodes. Now that's just implementations of more generic interfaces that we have. So essentially, you could say that we've got an events broker and a global FDB. There's a few implementations of each. I think you can use PubSub. You can use for Zookeeper, you can use DynamoDB. So there's a few out there depending on what cloud you guys are using. What is currently in K8s Gerrit? So you have high availability, as I was mentioning. But it's a single cluster with the multiple Gerrit primaries. You've got a few requirements like the load balancer using HA proxy for traffic distribution, shared Git repositories facilitated by a shared file system, as I was mentioning. This means that you're then sharing your caches, your secondary indexes, your stream events, your web sessions. That's all shared on the file system, and there's no synchronizations between the various nodes happening on that level. So this is what it looks like at the minute. I think Matthias showed this already earlier, but just to make sure, your primaries are using the shared Git repos, and your replicas are also reading from the same Git repos. All right. So at some point, that's going to become a bottleneck. At some point, you're not going to be able to scale, and it's also a single point of failure. I know NFS is distributed, but something happens, it still goes down. So we had a few targets with K8s Gerrit. First one was the stateful set with 3 replicas. As I was mentioning, 3 Gerrit primaries is really the minimum. No shared file system. Your Git data is replicated via a pull replication plugin. How many people know here about pull replication? Okay, a few, fine, but not everybody. Few differences with push replication, but we can talk about it later on. Uses Gerrit SSH and the REST API. To talk between the two, between the nodes. So moving on. This is what K8s Gerrit infrastructure looks like. So you've got all of your nodes. each one has got its own data and its own site. So each node is like completely separate, and it's a share nothing architecture. So you add a new node, you're adding new capacity. Like you're not just the thing with NFS, it's a bit of a diminishing return kind of system. Like you have got 5 nodes, you add a 6th node, you don't get like 100% improvement, right? You get like a little bit less. You have the 7th node, you get less improvement as well. You had an 8th node, it's a bit less as well. While with not sharing any file structure, any file system, you can just like keep a consistent amount of capacity that you're adding to the system every time that you're adding a new node. Now, looking a bit at the nitty-gritty of it, so you've got your Kubernetes deployment descriptor. So Matthias this morning was mentioning it. Oh, I can't really see it too well there. But Matthias was mentioning this morning about all of the stateful sets and all like that and all of that stuff. So this is how you configure it. You can't really read it, so I'll read it for you. So this is the storage class, which is just standard at the minute. You've got your replicas. So you've got 3 replicas there. You want to add the 4th replica. You just press 4, restart, redeploy it, and a new node is added for you. So I'm sure a lot of people wish they could expand their Gerrit installation as easy as that. Down here, you've got, what's this? Sorry, I can see it better here. This one here, your node type. Now, this is a primary node. If you want to create a replica cluster, you just change that, start it, and it will be a replica cluster, right? If you want to switch it back, primary, as easy as that. There's really not that much more going on. This is what the config map looks like. So if you have multiple Gerrit primaries, you will need to fiddle with the config. That's always a pain. And then you might even end up in situations where different servers have got different configs because someone went and edited manually. So that's always a big pain I found. With Kubernetes, obviously, you get a much more aligned and streamlined management of the configuration for you. Anything else to send here? Yeah, so all of the secrets are stored in the Kubernetes secret manager. I don't think there's too much else here, so I think that's good to go. This is what it looks like. So actually, each pod is actually each container is actually 2 pods. So you've got your Gerrit init container, which takes care of doing all the initialization of the site for you, and then you've got your Docker container, which is like the actual Gerrit one. So this is ephemeral. As soon as this has done its job, it dies, and then that starts up and starts actually serving the traffic to the incoming nodes. So yeah, we've got some libs. What libs and plugins are we using at the minute? So libs, Global RefDB, and Events Broker. Plugins, you can see here, Zookeeper, Kafka, Web Session Broker, cool one. So for those of you that don't know, so the way that, and I'm going to show this in a second, the way that we allow Gerrit, different primaries, to know if a user is logged in or not is through the Web Session plugins. We use the Web Session Broker. I think there's a fluff file one as well that simply uses a file. But yeah, in this way, we synchronize the web sessions between all the nodes. Obviously, the multi-site and pull replication plugin, which I might mention a bit more in a second. Yeah, how do the nodes catch up? So say that a pod goes down and it starts back up, and so it's missed the information that has happened during the period of time that it wasn't running. How does it catch up? How does it know that all of the information? How does it get all of the information that has happened in that period of time? Well, we recommend setting consume stream events to false, so we don't use the internal Gerrit stream events buffer. We rely on the broker, so because that's more reliable. So we just read from the broker, get all of the events, and that's pretty much it. Not too much to it. So what I've got here is 3 separate nodes. This is running in GCP. If you go, so this is running all in GCP. So you can access it. Well, this is locally. I could have accessed it with gerrit.poc.com. I've got a Gerrit Meets repository. This is an old demo. So if I sign out from it, I'm going to try and re-sign back in, and you're going to see how it's actually going to sign me in all the different nodes. So now we're going to go on to node 1, I believe, in a second. What was I doing here? All right. So we see that, I'm currently signed out. So if signed out from, this is 8081, so this is the 2nd node, and this is the 3rd node, so 8082. So now if I sign into one of them, with some time. Okay, I wanted to show that if I sign in, I'll go on the first node, I sign in, I do a review, so I select a change, I do a review. Yeah, that's pretty much it. If I go here and I reload, that's already been replicated to the other node. That's already ready to go. Same thing with the last node, this is already ready to go. And I am signed in. So yeah, that's pretty cool. So here, quickly looking at some config, which you don't really care about. So what I'm going to try and do now, maybe let me pause this. So what I'm going to try and do now is, well, let's see how quick it goes. So I've got 3 different repositories set up locally. They've all got 3 different remotes, so you can really see it here, but this goes to the first node, this goes to the second node, this goes to the third node. So what I'm going to try and do is create a new commit. If this starts, create a new commit. It's going to have the same exact change ID. So I'm going to create this at the same time, and it's going to have the same exact change ID across all 3 nodes. I was thinking about this. There we go. Yeah, so I'm going to fetch. Everything is up to date. Fine. Give a set to master. So we're all at the same point. And then I'm going to, yeah, create a new commit here. Getting the timing right is always hard, eh? All right. So yeah, create a new commit. I believe I'm then going to go and change the message in each node just quickly, just so that the message is slightly different, but the change ID is going to be the same. No, I'm going to stop now. Hey, fast forward a second. Yeah, we see that I'm amending the commit just to say something different, but yeah, can you see? You can probably see a bit better here. But the change ID across these 3 is all the same. Now that I've paused that, this is going to come and bite me. But yeah, so now we try and push this. So yeah, I'm going to push directly to master, and boom, it's going to fail, telling me one of them succeeded. So this all went well, and these other 2 failed. Do people understand how this happens? Or yeah? I'll explain. So essentially, global refdb, when the nodes go and push to a certain branch or creating new changes, when they go and push to a certain branch, what they're going to do is they're going to go and check in global refdb if they have the latest version. All right. So and only one of these nodes is going to be able to write at one time, right? So say that they all start at the same point, they all go and check in global refdb, like I'm going to write, this is the parent of the commit I'm writing, is that the latest one that I've got? They'll say yes. Well, one of them will say yes, fine, writes that commit. Then the other 2 will say, well, it will fail for the other 2 because the other 2 are out of sync at this point. So it's going to say, no, reject this because you're not up to date with the latest thing, with the latest commit. So reject the write, it's going to fail for the client. The client is then going to need to fetch, and it's going to have the latest up-to-date information, and then they can repush or whatever they need to do. You're looking at me. I have a question. Okay, I have a question. All right. So yeah, now if I do a git fetch, you can see how on the last node that obviously is all up to date already, and this has pulled the latest changes. Now I'm going to try and do something slightly different. So what I'm going to try and do is push at the same time those 3 new changes. Yeah, at the same time push 3 new changes. So instead of pushing to a branch, I'm going to push three changes at the same time and see if that succeed. You could think, as Martin was rightly pointing out earlier, that because they're writing at the same time, they might try and get the same change number. But this doesn't happen, and we'll see how that works. So essentially, what we're going to be doing here, this has finished. Oh, it beat me to it. Sorry. But you can see how I went to push 3 different commits. But this time, instead of pushing to master, I did head refs for master. So instead of pushing directly to the branch, I created 3 separate changes, and that succeeded on each node. So this is 3 different developers. They all push their change, and it succeeded for everybody. If you probably can't read, but you're going to see that it's going to have very different change numbers. So it didn't clash on that because each node gets a window of numbers to which it's going to assign the change. So yeah, this is 29, this is 46, and that's 6, whatever. Yeah, that I think was pretty much it. A bit of a quick one today. Any questions? All right, Kaushik. If a pod goes down and has writes that have not been synced with the other pods, can the writes be recovered at all? Good question. Yes, because essentially, this is a loaded question actually. Pool replication replicates in a few different ways. So if the payload is smaller than the certain amount, it will actually try and replicate asynchronously to the other nodes, right? And because that is extremely quick. All right, and it's going to do it before it gives success to the user. So by the time your git push is finished, you're already synchronized to all the other nodes. All right. However, if that fails, because it could fail for many reasons, the node is trying to write to is down, the node is trying to write to is behind, so it can't accept the payload as is, it needs to do an actual fetch. Then it will put an event on the broker, and then the other nodes are going to try and pull from it. However, yes, if that node goes down irreparably before you push, before it has managed to replicate to the other ones and you don't manage to recover it, then that's a problem. But usually, you should be able to recover the data from the disk, or it's a bit rare that get fully corrupted. So the question is if we run into any problems with the multi-site plugin where we actually lost any data, and no.